Hi Olivia, this is a video to go with the section in your textbook 3.2 Part 1, Solving Systems Algebraically. Okay, I think you've seen these problems last year. The first way to solve a system is, well, let's back up real quick. To review, a system of equations is something like this, okay, where you have two equations paired together, and to solve or look for a solution means to find the one point that's going to fit in both of these equations. Alright, so basically these are lines. If you were to graph these, it would look kind of like this, and there's going to be one point right here where they intersect. Now sometimes you have ones that don't have a solution. Those are parallel lines if they don't intersect. Alright, so if you get a problem that doesn't seem to be working out in your homework, then maybe there is no solution. But if there is a solution, it's going to be a single point, and you should get answers like maybe like x equals 3 and y equals 5. Okay, so we would be able to plug those numbers into the two equations and have them both be true. Okay, so the first way to solve one of these systems is by using substitution, and you might remember doing this. So basically the goal is to take one of these equations and solve for one of the variables, either x or y, and then replace that value into the other equation. All right, so let's try it out. Now this one, you usually pick the variable that looks the simplest. All right, so in this case we have a y here that doesn't have a coefficient in front of it, so that one would be pretty easy to solve to get that y by itself. All right, so I'm going to pull out just that equation, 2x plus y equals 10, and solve that for y. So to get y by itself, I need to move this 2x. All right, so subtract 2x and move it to the other side. All right, so now what I have is an expression that's basically the exact same thing as y. So if I wanted, I could go back to either of these equations, and I could fill in that expression instead of y. So what I want to do is use this in the other equation that I didn't already use. The 3x plus 4y is 12, but instead of y, I'm going to put a parentheses and replace the y with what it equals, 10 minus 2x. Okay, so that's the substituting part. Okay, and then next I want to try to simplify and solve for x. So I should be able to do this because there's only one variable, just an x now. Okay, so you can distribute next. That's a good idea. Okay, so 4 times 10 is 40. And then 4 times negative 2x is negative 8x. Alright, let's see, we could combine like terms next. We have a 3x and a negative 8x. So 3 minus 8 is negative 5. Okay, and let's see, I could move the 40 to the other side. And 12 minus 40, let's see, that is negative 28. Okay, and then finally divide by negative 5 to get x by itself. Alright, let's see, we can do two negatives, those can cancel out. Two negatives is a positive. Oops. Alright, and then that leaves you with 28 over 5, and you can leave that as a fraction. All right, or a decimal if you want, if it works out nicely. Let's see, as a decimal, this one is 5.6. Okay, so now we know what x is, and then there's just one other step to the problem, and that's figuring out what the y is. So you have two options here. You could go back to this, this equation. That's already solved for y, so that might be nice to plug the value of x into that one. Or you could go back to either of the original ones and substitute the value of x into one of those. Alright, so I'm going to pick this this one here, I think this will be the easiest. So we're going to bring this value of x over and, all right, substitute that in. So we have y equals 10 minus 2 times 5.6, or the fraction form. Okay, that's 10 minus, and let's see, 5.6 times 2 is 11.2. And then 10 minus 11.2 is negative 1.2. Okay. Okay, so we have our solution, negative 1.2 for y and 5.6 for x. All right, so you can write this one of two ways. If you want to just kind of write this out, the values of x and y, and stop, that works. All right, or you could also write this as a point, because it is a point where those two lines intersect. Oops. Okay, so that's the solution, and then let's just do a quick check so that we can kind of review how to do that. What we're checking for is to see if this point, these values of x and y, make both of those equations true. Alright, so if we replace the x with 5.6 and the y with a negative 1.2, hopefully this equals 12. Okay, so 3 times 5.6 is 16.8, and then 4 times negative 1.2 is negative 4.8, and when you subtract those, that does actually equal 12. Alright, so that one works. Then the second equation, 2 times 5.6 plus negative 1.2, and oops, that should be an equal sign. Okay, hopefully this equals 10. Alright, 2 times 5.6 is 11.2. And when you add those together, that does equal 10. Alright, so if it had only made one equation true, then that's not a good solution. It has to be both. Alright, here's another one if you want to maybe pause and try this yourself, and then maybe restart the video and I'll kind of walk you through the solution. Okay, so here we go. Now this time it would probably be easier to solve for x, since that's the one that's kind of by itself. It doesn't have a coefficient in front of it other than 1. So I'm going to pull that equation out. And solve for x. Alright, subtract 3y. Okay, so x equals 5 minus 3y. Okay, and then I will substitute that into the second equation, the one that I didn't use yet. So I have this expression, the 5 minus 3y, that's the same thing as x. Alright, so instead of x, I'll put a parentheses and then write that in. Alright, so now this time we're solving for y. And let's multiply, let's distribute the negative 2. Negative 2 times 5 is negative 10. Negative 2 times negative 3 is positive 6y. Minus 4y is negative 5. Combine like terms with the y's. 6y minus 4y is 2y. Alright, trying to get the y by itself, so let's move the number over. Let's add 10. And, alright, then 10 minus 5 is 5, and then divide by 2. And it looks like they really like decimals, this section. I think they're trying to give you ones that would be harder to solve graphically, so that way it gives you like a motivation to use algebra to do it. Alright, so now we know what y is, and let's take this back to over here to the equation that's solved for x, and substitute in what we know y is now. Alright, so in parentheses 2.5. All right, so we have 5 minus, and then distribute 3 times 2.5. That is 7.5. Okay, and then subtract 5 minus 7.5 is negative 2.5. All right, so your solution, you can kind of leave it like that if you want to, or as an ordered pair, a point is negative 2.5, 2.5. All right. All right, let's try problem 2. All right, using substitution to solve a problem. So same sort of an idea, but this is a word problem, so we actually need to write the inequalities, the equations before we solve them. All right, a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, software, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? All right, so systems of equations, we write these when we have two variables, an x and a y. You can also use other letters. So in this problem, I would look at this last sentence. This is going to tell me what the variables are, the two things that I'm trying to find. All right, so we have the cost of the lesson and the one-time fee are the two things that are unknown. All right, so I will use a C for cost and an F for fee. And then we need to write two equations, and both of them need to have a C and an F in them. Okay, so first of all, we have, looks like we have two different prices here, so I'm going to kind of use these as my two equations. 6 lessons is $300, all right? And then that includes a one-time fee. All right, so we have kind of two components going into that cost. We have the lessons, and then we also have the fee. All right, so we have 6 lessons. Each one costs C dollars, whatever that is. All right, and then you add in the one-time fee, and then altogether that equals $300. All right, so like if we had, if the cost of a lesson was like $10, then you'd have, 6 times 10 here, and then whatever this fee is that makes that equal 300. Okay, the second situation, 12 lessons for $480. All right, so this time 12 lessons at whatever the cost is per lesson plus a fee equals 480. Okay, so there's the system, and you may have noticed the last couple had kind of like a curly brace there, and that curly brace kind of just pairs those two equations together. All right, so let's go on and solve this. Okay, so we'll use the same technique. Let's use substitution. Now f looks like it's going to be the easiest to solve for, or get by itself, and either equation would work, so I'll just choose the first one. Okay, and to get f by itself, need to subtract 6c. Okay, and I didn't use the second equation yet, so I'm going to substitute into that one. 12c plus f, and so instead of f, I'll write this, 300 minus 6c. No multiplying in this one. There's no coefficient in front of f, so I'm going to skip the parentheses. And that equals 480. All right, so combining like terms, 12c minus 6c is 6c. Okay, and I want c by itself, so I'll subtract 300. 6c equals 180, and then divide by 6. And we get c equals 30. Okay, then to bring that back over to the other equation that already has f by itself, substitute in the c. All right, 6 times c is 30. All right, and we get 300 minus 180, and that equals 120. All right, now you can kind of choose, now for this one, like to write an ordered pair, usually we go alphabetical order. So if you write an ordered pair, you'd put C first and then F, right? Or in this case, it may just be easier to kind of, box in your answers and leave them just as C equals and F equals. All right, so if we wanted to go back and answer the question, what is the cost of each lesson? That's the C, that's $30. And then what is the one-time fee? That's the F, and that's $120. Okay, why don't you try this one? Pause if you want to, and just see if you can write the system of equations on this one. You don't have to solve this one. Okay, and then I'll give you the answer in a second. Okay, so an online music company offers 15 downloads for a certain price, 40 downloads for a different price, and then that price includes the same one-time registration fee. Okay, we need the cost of the download and the registration fee. Okay, so let's use D for download, or if you want X and Y, that works too. All right, or really any variable that you like. And registration fee, I'll do an F again. Okay, so 15 downloads is $19.75. So 15 downloads times whatever the cost for one of those is, plus the fee, equals a total of $19.75. Okay, and then 40 downloads, okay, 40 times whatever the cost of a download is, plus a fee, and the total cost is $43.50. All right, and that's it for that one. Okay, and then we run out of examples in the text itself, so if you look on page 156, there's a lesson check, so I thought we would just do a couple of those. All right, and I'll go through these a little more quickly, and you can kind of pause and look through the work if you need more details about these. Okay, so first one, number 1, looks like it would be easier to solve for y. And yeah, pause and do these yourself if you want the extra practice. All right, or if you're good to go, then maybe just skip ahead and try the homework. All right, I'll solve for y in this equation. Okay, so I'm going to subtract 2x and get y equals 4 minus 2x. Okay, and then I'm going to substitute that into the first equation. So get 3x plus 5, and then instead of y, 4 minus 2x. All right, and then solve for x. So this time we have some distributing to do. 5 times 4 is 20. 5 times negative 2 is negative 10x. Okay, combine like terms. 3x minus 10x is negative 7x. All right, subtract 20. And that's negative 7. And divide by negative 7. Okay, this is a nice one. X equals 1. Okay, and then I'm just going to take this back to the equation that's solved for y, or either of the two original ones would work. All right, I'll substitute in 1 in place of x and simplify. Okay, so 4 minus 2 times 1 is 2, and 4 minus 2 is 2. Okay, so I get y equals 2. All right, so your answer is the 0.12. All right, a second one. Okay, now this one, you have an x and a y that both have a coefficient of 1. So I would say either one is equally easy to solve for. All right, so you can take your pick, and I don't know if you're pausing this and trying this along with me. Maybe you'll pick a different one than I picked. So just see if your answer at the end is the same, and then you'll know you're on the right track. All right, so I will get I'll get x by itself, so I'm going to subtract y. Okay, and then I'll replace that in the first one in place of x. So 2 times negative 12 minus y minus 3y equals 6. All right, and then distribute. 2 times negative 12 is negative 24. 2 times negative y is negative 2y. Whoops. Minus 3y is negative 6. Okay, negative 2y and negative 3y is negative 5y. I still have a negative 24, and that equals 6. All right, add 24. Negative 5y equals 30. Divide by negative 5, and you get y equals negative 6. And then bring it back up, substitute it into this equation. And you get x equals negative 12 minus y is a negative 6. I'm going to move that one over actually. Minus a negative 6. Okay, so minus a negative is a positive. All right, and negative 12 plus 6 is negative 6. All right, so your solution is negative 6, negative 6. All right, and then last problem, this is number 3 from the lesson check. This is a word problem. A cafe is selling regular cups of coffee for $1 and large cups for $1.50. Melissa and her friends buy 5 cups of coffee and they spend $6. And you're asked to write a system of equations and find the number of large cups that they bought. Okay, so this one, you're only asked to find one thing, so you kind of have to look back through the problem to see what your second variable could be. So in this case, we also have that other size cup, the regular ones, so that's the other thing that's unknown. All right, so we need to know the large cups, and I'll use like a cursive L for large. All right, and then an R for regular. Okay, so we need 2 equations that each have an R and an L in them. All right, now this one, the setup for this is kind of similar to the 2 word problems that you have in your homework, so I thought we should go through this. It's a little different than the other 2 that we did. Basically, you have some information about the cost of the cups, and then you also have this sentence, the buying 5 cups and the spending $6. So a lot of times what happens is you end up with 2 equations, one for kind of like the quantity of things, and then another that talks about the cost. So one setup we could have would be like the total number of cups that they bought is 5, and then the total number of dollars that they spent is 6, and then we can kind of go from there. All right, so the quantity, we just have to add the 2 things together. The regular cups that they bought plus the large cups equals 5 cups altogether. All right, so it could be like 3 and 2 or 1 and 4 or something like that. Now the other equation, this is the cost. So we need to multiply here. It's $1 for a regular cup. So 1 times R is the cost of all of those regular cups that they purchased. All right, or you can just write R. All right, and then large cups cost $1.50. So it's $1.50 or 1.5 times however many large cups they bought. All right, so that kind of gives you the 2 coefficients for those variables. All right, and I'm going to erase this 1 and just leave that as an R. All right, so there's your system, and I think you know what to do from there. We need to solve, and you can choose either R or L. Both of them, you know, in the first equation, both of them have a coefficient of 1. All right, so if you choose R, for example, let's do this one on the next page. Okay, so let's solve this one for R by subtracting L. Okay, and then replace that in the second equation. Right, so instead of the first r, I'm going to write 5 minus L plus 1.5 L equals 6. Combine the L's, so this is like negative 1 L plus 1.5 L, and negative 1 plus 1.5 is positive 0.5. Okay, subtract 5. You get 0.5 L equals 1, and divide by 0.5. Okay, and 1 divided by 0.5 is 2. Okay, so they bought 2 large cups of coffee. Alright, and then we just need to find L now, so let's take this back up to this equation that's solved for R, and you get R equals 5 minus 2 in place of L, and R equals 3. Okay, so 3 cups of regular coffee and 2 large cups of coffee. Alright, that's it. So your homework is page 156, numbers 5 through 12. Okay, and then just a couple suggestions for those word problems. There's one about bills and money. Alright, so one variable or one equation could be the total number of bills, and then the other could be like the cost of those bills. Alright, and then there's a second problem that has to do with a youth group. And I think the trick to this one, that you've got basically like vehicles and total number of people. Alright, so you have, it says 5 chaperones. Alright, so you have basically 5 vehicles going. So think about like the cars and the sedans. Or sorry, vans and sedans. Okay, so you have 5 total. And then think about how many people can go in a van and how many people can go in a sedan, and what's the total number of people going on this trip. Okay, so that should help you write your 2 equations for that one. Alright, see what you can do with that, and if you have questions, send me an email, or I will talk to you when you get back. Alright, that's it. Bye.